Alright, so we're going to go ahead and do the review for the trig test, which is tomorrow. Number 1, find the value of x in each figure simplified in radical form. Now for number 1, we're actually going to use our relationships of special right triangles. Because if you notice in number 1, if I split this down the center, this is an isosceles triangle, which would divide this into a 60-degree and a 60-degree angle. And I know that that's a 90. So that means that this is a 30-degree angle right here, 30-degree. And this is a 60-degree, which means this is a 30, 60, 90 triangle. Now, with that being said, if this whole side is 10 root 3, I know that half of it is going to be 5 root 3. So that's going to be 5 root 3, and this is going to be 5 root 3. And now it's just a matter of solving this 30, 60, 90 triangle. So since 5 root 3 is our longest side, I know that the relationship between the short side and the long side is times root 3. So to go to the other direction, I actually have to divide by root 3. So 5 root 3 divided by root 3 will cancel out the root 3's, and I'm just left with 5. So that means that this height here is 5. Now the relationship between the short side and the long side is times 2. So 5 times 2 is then 10, and x equals 10. Okay. For the next one, this is a 45, 45, 90 triangle. So the relationship between a 45, 45, 45, 90 triangle is that this and this side are the same, and this is root 2 times x. So I'm going to first use Pythagorean theorem to find the missing side of this right triangle, which is c is equal to the square root of 4 squared plus 3 squared. So that means c is equal to 5. So I know that the hypotenuse of that right triangle is 5. And now I have to take that 5, and since I know that it's a side times root 2, I'm going to do the other direction. So I'm going to take 5 and I'm going to divide by root 2 to find x. And now I need to rationalize or get rid of the radical in the denominator. So I'm going to multiply by root 2 over 2, and that would be 5 root 2, and then root 2 times root 2 is 2. So I know my x value is 5 root 2 over 2. For my last one over here on number 1, I'm going to first again use Pythagorean theorem to find the hypotenuse. So that's going to be c equals the square root of 15 squared plus 8 squared. If you put that in your calculator, you get 17. So the hypotenuse here is 17. Since this is a 60-degree angle, I know that this is a 30, 60, 90 triangle. And therefore, this is the shorter side. So the relationship between the hypotenuse and short side is half. So this is going to be 8.5, and then I'm going to take 8.5 and multiply it by root 3 to get x. So it'll be 8.5 times root 3. You could also write this as 17 over 2 times root 3, or 17 root 3 over 2. So there's a couple of different ways you could write x. Okay. Number 2, in rhombus RHOM, RO is 27. And HM is 42, so we want to find the measure of angle R. Now for this one, we are going to want to draw our rhombus first. So in order to draw our rhombus, let's go ahead and we know that in a rhombus all sides are congruent. So there's a rough sketch of RHOM. So here's RHOM. Okay. We know RO is 27, so that's this whole side is 27. And I know HM is 42, so that's this whole side is 42. Now, excuse me, in a rhombus we know that these are 90-degree angles, and we also know that these segments bisect each other. So if this whole thing is 27, I know that each side of these is 13.5. So 13.5 and 13.5. If this whole thing is 42, I know that this one is 21 and this is 21. So if you notice now, all I have is a right triangle. Now, I'm going to pull out this right triangle right here. And that right triangle is going to look like this. Okay, I'm just going to make it a little bigger. This is R, and this is H, and then this is the 90-degree angle right here at the intersection. Okay. Again, this is 13.5 here, and this is 21. Now we need to find angle R. Okay, here's angle R right here. I also know in a rhombus that these angles are bisected by the diagonals. So if I find this angle and double it, I will find all of angle R in the rhombus. So I'm going to look for angle R first, so that's going to be theta. Notice that I have opposite and adjacent, so I'm going to use tangent. So tangent of theta equals opposite over adjacent. To solve this, I'm going to have to do inverse tan. So tan inverse of 21 over 13.5 is going to give me theta. So tan inverse of 21 over 13.5 will give me 114.53. Okay. All right, actually, I think that'll give you half of that first. So if you want to do, and that's actually the actual angle for angle R. So if you do tan inverse of 21 over 13.5, it's going to give you 57, and then if you multiply it by 2, you'll get 114.53. So theta is actually 57.264, and then double it. Okay. Multiply it by 2, so angle R is actually equal to 114.53. All right, now to get the other angle, I know that for angle H, that's going to be the supplement of this angle here, angle R. Because remember, consecutive angles in any parallelogram are supplementary. So all I have to do for angle H is take 180 and subtract that angle that I found. So angle H is equal to 65.470. Okay. So here's angle H, and here's angle R. All right. That's 1 and 2. Number 3, you need to draw a picture. So a monument stands on level ground. Here's your level ground. Here's the monument. Okay. It says that the angle of elevation to the top of the monument taken at the point 325 feet from the foot. So I know this is 325 feet. And the angle of elevation, so here's angle of elevation, is 27 degrees. It wants to know how high the monument is, so this is x. So what are you going to use? This is opposite, and this is adjacent, so you're actually going to use tangent. So tangent of 27 equals opposite over adjacent. To solve this, you're going to multiply both sides by 325 first. And then in your calculator, you're literally going to put in 325 times the tangent of 27. And you're going to get that x is 165.596. For number 4, from the top of a 108-foot high building, so here's your building. I know it's 108 feet tall. It says the angle of depression to a bike on the sidewalk. So here's my bike over here. Okay, you would think it's that, but it's going to actually be this angle right here. This is 29 degrees. So I'm actually solving this upside down right triangle. This is also 108 feet. And you are trying to find the distance the bike is from the base of the building. So this is x, which is basically x up here. Okay. So now this is the triangle you're solving. You have opposite and you need adjacent. So you're going to again use tangent. So tangent of 29 equals opposite over adjacent. In this case, you can just cross multiply. So x times the tangent of 29 is equal to 108. Divide both sides by the tangent of 29. So the tan of 29's cancel, and in your calculator, you're going to put 108 divided by the tangent of 29. You get 194.837. That's in feet. Okay. Number 5. In the diagram, the rectangle ABC diagonal AC is drawn. DC is 47, DE is perpendicular to AC, and DAC is 63 degrees. So you basically need to find X in order to find the area of this rectangle. So let's first look at this triangle right here. If I look at this big triangle right here, I know that basically this is 63 and this is 47. So that side here is actually the opposite side. You actually don't even really need to know that DE is perpendicular to AC, because you already know it's a rectangle, and that information really doesn't help us at all for this problem. So if you want to just kind of ignore that information, that's other information that we actually don't need. Okay, so ignore that. I'm just going to kind of scratch that out. Okay, because we don't need it. Now if you take a look now at the big triangle that was created here, now you can see that this is a right triangle, and this is an opposite, and this is adjacent. Okay, so in order to find that, you're going to do opposite over adjacent and x. So what is that? That's going to be tan. Okay. And now I'm going to solve this. So I'm going to cross multiply x times the tangent of 63 equals 47. Divide both sides by the tangent of 63. And x is equal to 47 divided by the tan of 63. And you get 23.947. Okay, now that you have x, now all you have to do is multiply to find the area. You have to multiply 47 times that answer, 23.947. So 47 times 23.947 is going to give you 1,125.509. Alright, number 6. A hang glider takes off from a 300-foot cliff. So here's your cliff. Your hang glider takes off. Angle of depression again. So that's again going to have to draw that horizontal from the cliff. And this is your 17-degree angle. So this is actually the right triangle you're solving. They want to know how far the glider flew in the air. And also how much ground distance. So we need x and we need y. We also know that this cliff was 300 feet, so this right here is 300. So the first thing I'm going to do to find y is opposite and hypotenuse, so that is sine. So sine of 17 equals opposite over hypotenuse. So again, solving this equation will be y equals 300 divided by the sine of 17. So y equals 1,026.09 feet. To find x, you can use tangent, because that's opposite and adjacent. X is adjacent. The 300 you know is opposite, so that's tangent. So tan of 17 equals 300 over x. And then again, solving that the same way, x will equal 981.26 feet. Alright, I'm actually going to stop the video here and complete the rest in a separate video.